All right, in proving two triangles are congruent, we really only have one tool at our disposal right now, and that is the side angle side congruence theorem. Notice in this picture of two triangles, we already have a pair of sides and a pair of angles that are congruent. So now all we need is an angle that's included between these two congruent sides. And that would be these two vertical angles. All right, so to prove that the triangles are congruent, we're going to use the SAS congruence theorem, and the proof would look like this. We would start with the given. Side AC is congruent to side DC, and side or segment BC is congruent to side EC, given. Step 2. These angles are congruent. And the reason? All vertical angles are always congruent, or just the vertical angle theorem. Now that we have that, our triangles are congruent. We're there. Destination achieved, and the reason will be the SAS congruence theorem. Final statement 3, the triangles are congruent by the SAS congruence theorem. All right, we've achieved the proof. Now they want us to find the values of x and y that make that true. No problem. This side is congruent to that side, and this side BC is congruent to this side EC, or 3y plus 1 is equal to 4x. All right, well, this is one of those systems of equations, and to solve the system of equation, we can use a substitution method or the elimination method. I'm thinking I'm going to use the elimination method this time. So I want to write these two forms, these two equations, so that they look structurally the same. Get all my x's and y's on one side and all the numbers on the other side. So subtracting 2x from both sides and adding 6 to both sides, our first equation is now that. Subtracting 1 from both sides of this equation and subtracting 4x from both sides, our second equation looks like this. And now we can use the elimination method. Notice the coefficients on x are just off by a factor of 2. And in the elimination method, we would like the coefficients to be opposites of each other. So if we multiply the top equation by negative 2, we'll have 4x, which is the opposite of negative 4x. Be sure to distribute on this side, giving us negative 8y plus 4x, and on the right side is negative 24. All right, our coefficients on x are opposites, so now we will do the next step of the elimination method. We'll combine these. On the right side, we have negative 25, and on the left side, 4x and negative 4x is 0, leaving us with negative 5y. And when we divide both sides by negative 5, y is equal to 3. So if 3y plus 1 is 4x, and y is equal to 3, then we have 9 plus 1 is equal to 4x. So x is 10 divided by 4, or 2.5. And there we have it. We've proven that the triangles were congruent, and x would have to be 2.5, and y would have to be 3.